All right, so now 4.25, we are going to be looking at modeling for our trig equations. So let's look at, here's the general form. F of theta is A times sine B times the quantity theta plus C plus D. You can think of the theta as like X or T. So in example A, I have a graph, okay? Graph A. So if you want to write y equals A sine B times X minus C plus D. Okay, let me identify the different parts. A is connected to the amplitude, but if you have a reflection, A can be negative. To find B, you find that from 2 pi over B is equal to the period. C is the phase shift if it's in this form. And D is your vertical shift, and it's connected to the midline. So right now, do you see this graph goes from -1 to 5? See, this is going from -1 to 5. So that is a total distance of 6 units. So my amplitude is half of that distance, which is 3. And we're going to do one that is a sine curve and one's a cosine. So this is where it's going to get a little bit tricky. So I want to do my midline. Half the distance is 3, so I can count either from the bottom or up. So the midline is y equals 2, so that means D is 2. If I'm going to use the sine curve, there is no phase shift, so C is 0. Then you want to go, I don't have the entire graph. So what I want you to notice is if I go from the minimum to the maximum, what is that distance? It's going from -2 pi to 2 pi. So my period length is, that's 4 pi, and that's half. So the period is 8 pi. So then what you're going to do is you are going to take 2 pi over b is equal to 8 pi. So 2 pi is equal to 8 pi b, so b is 1/4. Since this curve goes up, my a value is positive. And the sine curve is at the midline. Cosine is either the hill or the valley, okay? So then here's my equation. Y equals 3 sine, this is going to be 1/4. There is no phase shift, and then it's up 2. The a value, so now there's 2 different ways I can, in fact, do the cosine. So my cosine can start up here at the hill. If I'm going to start at the hill, then my phase shift is right 2 pi. So then here's this equation. Since it's at the hill, it's a positive. The b value is the same, and the vertical shift is the same. So the only thing that really changes when you go between sine and cosine is your phase shift and potentially the a value. Okay, so now let's look at table B. So like I'm giving you a graph, and how do we figure it out? And then I'm going to give you a table. How do we figure it out? So what I want you to notice, a few things here in the table. The period length is 15. And how I know that is it goes through a max to a min back to that max. So 2 pi over b is 15. That's like 15 over 1. So 2 pi is 15b, so b is 2 pi over 15. All right, so if you could imagine the midline, 290 to 310 is a total of 20. So my amplitude is 10. The midline then is going to go y equals 300. So the d is 300. With cosine, so I'm going to do cosine first. If this is 0, 3, 10, there's no phase shift. And it's up at the maximum, so the a value is the 10. Cosine 2 pi over 15x plus 300. Now, if I want to do a sine curve, I've got some options here, okay? I've got some options for the sine curve. If I want to start here, which is in the middle, it's going down. So I would actually have a reflection. If I go ahead and go all the way to 11.25, then I have the sine is going up. So I'm going to go ahead and go with that one, a phase shift of 11.25. So this will be y equals 10 sine 2 pi over 15 x minus 11.25 plus 300. All right, then example B. As you ride a Ferris wheel, your distance d from the ground varies sinusoidally with time. When the last seat is filled and the Ferris wheel starts, your seat is at the position shown in the figure at the right. Let t be the number of seconds that have elapsed since the Ferris wheel started. You find that it takes, let me go ahead and make a table here. It takes 3 seconds to reach the top, which is at 43 feet above. The diameter is 40, and this little distance then is 3. It takes a total of 8 seconds, so the period length is 8 seconds. So what that means is if I go all the way to the end of my table, 1, 2, 3, 4, 5, okay, it's going to take me a total of 8 seconds. So halfway would be 4 seconds. So then halfway is 2 seconds. So here are my time values. Then I want you to think about this as I'm rotating, and it says it is going clockwise. So if I come here, I've come down 20 units, so I'm at 23. And then as I go here, I'm at 3, and then you go back up around. So it might help if we made a sketch. Some of you will need the sketch and some of you will not need the sketch. So, and again, this is not for perfection, but at 3 seconds, I'm at 43, 5 is 23, then I'm down at 3. So what I have then, 2 pi over b is 8 seconds. That's 2 pi is 8b, so b is pi over 4. My midline is y equals 23, so d is 23. The amplitude is half the distance, so the a value is 20. And it says just write an equation. It doesn't say which type, sine or cosine. So I'm going to choose cosine, and if I choose cosine, then I have a phase shift to the hill would be 3. So I'm going to say y equals 20 cosine pi over 4 x minus 3 plus 23. Now I'm going to reread this because it says this is the distance, so I could say distance equals cosine pi over 4 t minus 3. Okay, there you go.